This section will discuss various ways to describe the concentration of a solution. There are many ways to express how much solute is dissolved in a solvent. Some common concentrations are given. Molarity, which we've been working with in previous chapters, is given the symbol capital N, M, and is the moles of solute per liter of solution. Molality, which is lowercase m, is the moles of solute per kilogram of solvent. Okay. Mole fraction is just the fraction, so how many moles of solute over how many total moles. So think of that as the part of the whole. Okay, mole fraction, so moles of solute over total moles. Percent by volume would be the volume of the solute over the volume of the solution. And percent by mass, grams of solute over total grams. Molarity is temperature dependent. Unlike the others, it is temperature dependent, and the reason is because it is the only unit that includes volume in its final result. So we would have moles per liter. We do have percent by volume here, but we have volume of both solute and solution, so we end up with a percent and not a volume unit. So why does the temperature affect the molarity? Well, as the temperature increases, the volume also increases, theoretically, okay, or generally. And so remember that molarity is the moles of solute per liter of solution. Okay, and so if we increase the volume by increasing the temperature, that's making the bottom of this fraction bigger, which means that the molarity will decrease. So as temperature increases, molarity decreases, and the opposite is also true. As temperature decreases, molarity increases. So we have an inverse relationship between molarity and temperature. Remember that solutions are homogeneous mixtures of pure substances in which the solute is evenly distributed throughout the solvent. Now, we often think of these homogeneous mixtures as things like maybe salt or sugar dissolved in water. So we have a solid solute and a liquid solvent where the overall solution is the liquid. But as you can see from this table, you can have all three states of solutes, all three states of solvent, but in every case, the overall state of the solution is the same as the state of the solvent. So the solute dissolves in the solvent homogeneously, and the resulting solution takes on that state. So you can dissolve gases in other gases. Air is an example of that. You can dissolve gases in liquids. We've talked a lot about that with carbonated beverages, or you can dissolve oxygen in water. You can also make solutions of two solids when making alloys. So you could dissolve silver in gold, and you get a homogeneous mixture that is overall solid. So as long as the resulting mixture is homogeneous, where the solute is evenly distributed throughout the solvent, then we have a solution that we can then express the concentration of.